Okay, so chapter 1 is a very short chapter, and there are just a few key points that you need to know. Then we'll get into measurement and metrology. Metrology is nothing but we're just studying measurement and measurement system, okay? We call that system of measuring. So what are we measuring? We're measuring the size, quantity, position, condition, and time. So these are just the early example of metrology. So here for mass, we started to measure by using something called Egyptian jeweler's balance. Okay, that's about 2000 before Christ. And then for length, we use something called Egyptian again, royal cubit. So that's about 3000 before Christ. And for time, we use this device, and we call that the Greek sundial, and that's about 200 before Christ. So this is BC. So we started to measure mass, length, and time way before Kings, long time ago. So these are just the early examples of metrology. So when we think about the mass, we want to know, how many of the little things that I have is equal to the big thing. Are they the same? So balance started off from there, and you put an object at one side, and then put other objects on the other side, and then see if they balance, meaning like they're equal, okay, in their height of this balance instrument structure. So if they're not balanced, you're going to see it weighted down here or weighted down here. So you put on this side or on that side and then see if they are balanced. They're just trying to see the weight or the mass, okay, of the objects that they're interested in. And again, if you think about the mathematics, we're adding the numbers here again. So here, some numbers of these little things are equal to a big one, okay, object right here. So not only maths that we're interested in the ancient time, okay, you're trying to learn what mathematics is, and then you're trying to learn how to balance one object and another by using this type of mass measurement or weight measurement instrument. At that time, they're just trying to figure out, okay, how weight, mass, and the numbers work. For the length, it's the same thing. We want to know how far away from one point to another. In order for you to know how far away from one point to another, you need to have a horizontal or vertical structure in order for you to measure that. So you know, oh, from this point to that point is about this distance far away, okay? And then we started to put the division, and then we started to put the units, different units for different division. Division is nothing but we equally divide, okay, the distance or the instruments measuring the distance. So anyway, at this time, you just need to know in ancient time, people are trying to study mathematics, people are trying to study mass, and then the distances between two or three things. And then get into something called geometry by trying all these measurements. And for time, it's pretty interesting. Actually, they started to look at the shadow, okay? Shadow of the trees, shadow of the building, shadow of themselves, which is completely corresponding to the position of the sun above us. So then they started to think, why is it moving? Why is my shadow moving around me? So that's the beginning of trying to understand, okay, if the world is round or if the world is flat or not. So anyway, the first observation is the shadow is moving according to the position of the sun. Okay, and then you start it off from the beginning of the day and then go all the way, and your shadow move, and then you get to the end of the day. So that's the beginning of the study. Time is nothing but your activities, okay, what you are doing, your physical activity. So the earliest time instruments are based on a shadow corresponding to the rays coming out from the sun, okay? And we call that the sun dial. Dial is because the shadow is going moving around, okay? Of course, we got only actually half of that, but then we completed by estimating the other half. It's kind of like making the mirror reflection of what we have known for the 12 hours, okay, approximately 12 hours in the daytime. Okay, so anyway, that's how people long time ago in ancient time got interested in measurement. Okay, so we use the measurement to make things. You definitely need to measure if you want to make something, okay? If you're going to start developing a one thing, meaning that you're manufacturing that part, and after that you need to measure that part so you can be able to manufacture, okay, the identical parts easily. So to make things you have to measure. Another one is to control the manufacturer. That means that you're using the part as the standards. So in that case, you also have to study. And the last one is for progress. Okay, it's kind of like keeping the records of our measurements so you can use it in the current time and modify or update or make it better. Okay, improve these parts or measurements for the future. So that's for the progress. We always go back and consult with the historic measurement. So the uses of measurements are to make things, to control the manufacture, and then for progress. So here when you look at this base units table, you can see this is your quantity, and then here are the corresponding symbols, and this column is giving you the name for the quantity and their symbol. So if you see length, we go by meter, okay? The unit is M, mass kilogram, kg. Your time is T, your unit is second. Electric current symbol is I, your unit is ampere. And then temperature is a big T. Your unit is Kelvin, K, and so and so, okay? So at this stage of your learning, all you have to know is we use a measurement to make the things, to control the manufacturer, and for progress. So when we use a measurement, you have a quantity, and we usually use symbol because we don't want to write, okay, full name for these quantities. And they're always linked to your physics, okay, physics. And here are the units, okay. We have many different unit systems, and this is one of them. So we call them the SI system. And these are the base units for these quantities. So at this point, what you need to know is in order to measure something, you need a part. You need a person who is going to measure that part. And in your measuring system, we use an instrument to measure the part, okay? And we're going to describe our measurement with a standard, okay, quantity, and we use a symbol to describe that quantity, and we use a unit, so you know how big or how far, okay, they are depending on your quantity of what you're measuring. So the base units are pretty important. So this is only a one system, okay, for the unit. We have different systems for units, and you're going to see in future slides. Okay, so when we measure something, you have to understand precision and accuracy, because when you measure something, you can come really close, okay, to the real measurement, okay. Real measurement meaning like, let's say if a point is about a meter away from the second point, that is the real measurement, okay, what it's supposed to be. But then I'm going to say you go and measure from this point to that point, which is supposed to be 1 meter. You might get like 0.9 meter, depends on the instrument you're using to measure that, okay. So I'm going to draw. So let's say I'll have a point here and I'll have another point there, and from here to here, the measurement is 1 meter. Go ahead and study that, okay, distance. So you go and you study that distance, and then you're going to use your own measurement. You measure this point, and then you measure the distance from this point all the way to here, okay. You might get like 0.99 meter. Or you might also get like 0.96 meter, okay. Or you might also get like 1.05 meter. So it depends on the person who is measuring that, okay. In this case, it's a distance. So precision and accuracy is we are looking at the measurement, okay, this one, done by somebody. So this is done by somebody. And you're going to compare that to the standard, okay. And if it's come really close, we call that accurate, okay. Accuracy is pretty good because your conformity is close to a standard. So you check your measurement by comparing it to a standard here, okay. So this is your standard right there. And we call that how accurate your measurement is. And again, every time you think of accuracy, you're thinking about standard, and you're thinking about your measurement compared to the standard and how close your measurement is to the standard measurement, okay. Precision, for precision is different. Precision, we're not doing this, okay. So let's say first time you measure, you got 0.99. Second time you measure, you got 0.96. The third time you measure, you got 1.05, okay. And you take a look at it, okay. So these data that you measure is showing you how, okay, how precise your measurement is. So when you look at it, you're not that precise because you have two close data right there, and you have one far away from the close data. So your precision is literally, okay, not as good. If you did get by measuring, okay, and you get like, let's say 0.98 instead of this, okay, for the third time that you measure. Now when you look at it, your effort in measuring this, and you took data 3 times, pretty precise, okay. There is no comparison, okay, between your data to the standard or in precision. Precision, you're looking at the time, okay, the number of times you measure a part, and then you look at your own data and see if they are all close together or if they're far away, okay. If you're getting like 0.8 one time, and then you go and measure, you got 0.9, and then you measure another time, you got 1.0. This is not precise, okay. That's pretty far away from each other, your data points are. This one is pretty precise. Every time you measure, you're getting 0.9, 0.96, 0.98. So if you round it, you're pretty good. Your precision is pretty, okay, pretty high because you're getting around 0.9, 0.9, 0.9. Okay, so for accuracy, your measurement, each measurement you are comparing to a standard of 1 meter right here in this example. For precision, you're looking at your own measurement without the standard. Okay, so that's the difference between precision and accuracy. And I truly want you to get that. Most people in the real world, when you go and work, you're gonna see they use precision and accuracy very loosely, okay? And you feel like they're saying the same thing because they don't know, okay? Now you know what is precision. You are comparing your own data, your own measurement. What is accuracy? You are comparing each of your measurement to a standard. So that's the difference between the precision and accuracy. Precision, gonna write it again, looking at the number of data you have taken to measure a part. Okay? Whatever you're measuring, it can be mass, length, time, but then you take the data, you measure this object 1 time, 2 times, 3 times, 4 times, and then 5 times. And then you look at your data. Okay, they are close to each other. So if you look at in a diagram, you're gonna see it like this. Okay, let's tell one like that. That's pretty precise. If your data came, your 5 points is not close, it's gonna come out like that. So one is here, one is there, and one is over there, and one is over here. Okay, and one is right there. So far away, so that's not precise. Okay, 5 measurements that you took. Now I'm gonna erase it again and draw it again for you. And if your data come out like this, every time you measure, you're getting like that. Meaning like you measure, your measurement system is pretty precise. Your instrument is good because every time you measure this thing, you're getting close. Okay, your data is pretty close to each other. Even this is a very exaggerated drawing. Okay, your points should be like this. Concentrate right there. Anyway, you get the point. For accuracy, you measure this. Okay, and then you're going to compare your measurement with an accepted standard. Okay, the standard say from here to here is, let's say, is 5 inches. And you measure it, you get 4.99. And you look at the standard, which is 5. So 4.99 is really close to 5, meaning your measurement is accurate. Okay? Here we go each measurement compared to a standard, accepted standard. For precision, no standard. You just measure, and then you look at the measurement you have taken and then see how close they are. If they are close, precision is high. If they are far away, precision is low. Okay? Alright, so now I'm going to erase this again. I hope you get it. So chapter 1, the key point of chapter 1. Well, you can read it in the textbook, a really long, bulky textbook. You can also look at the picture, it's repeating the same thing, okay? There's a big redundancy right in there. And what I was saying is for you to get what is precision and what is accuracy. Alright, the next one, acts and applications. So measurement. So again, you only have to know just a basic of acts. So acts and application is nothing but we're talking about only linear measurement here, okay? Application, there are so many of them, very, very diverse. And acts, very, very few basic acts, okay? And these are just telling you how a measurement how a measurement needs to be done, in which way, and how you have to obey some of the rules. And those are written right here in the Acts. Application, how are you going to measure? Okay, you can measure in many different ways by using many different kinds of instruments. You can measure time by using many different kinds of time measurement devices. Okay, you don't have to. But for ACT, it's just telling you how are you going to measure the time. Is more limited than applications. Okay. Anyway, don't stretch yourself in here. All you have to know is we're thinking about linear measurement. Applications, there are so many of them. Okay. Just like the cell phone application, right? For the social media, you have many different kinds of social media application. Oh my gosh, so many of them that you don't even know which one to choose to use it, right? X, it's just like there's only one act for social media, is communicating, and people everywhere, anywhere, anytime, right in the application. So that's an act. Yeah. And the regulation is have a net adequate, and then don't throw horrible comments in it, right? Behave when you put a comment or when you communicate with somebody online publicly. So anyway, same as that for the measurement. Okay, you have many different kinds of instrument to measure something, but there are very few ways to do that measurement. How are you going to do it? You need a instrument, you need somebody who's going to measure that, and you need a standard, and then you're going to use that standard. What kind of standard? They're going to have some sort of coding for that standard number. You follow that. You follow the measurement rules, and those kind of acts are very few. Okay, but how are you going to do that application? How are you going to apply that? Is going to come in many different ways. There are so many companies producing many different kinds of instruments measuring the same thing. Okay, so anyway, all right. So next slide. Codification of measurement. We code them. We code everything anyway. The language itself is a coding. Well, if you think about a water bottle, so we say we're gonna call this thing a water bottle. So that's coding. Okay. There is no absolute the absolute term for anything in the world. So that's going into philosophy. We are calling the water bottle because that's the way we name it. Okay, I can call the water bottle a cat or something, right? But that's the same thing. So anyway, so that's coding. So it's just a communication type, right? Now we're so limited to the language that we're using that we sometimes forget the real nature doesn't have language. The real nature doesn't have term. Okay, they're just things, and we are naming them in many different ways. Like you have your name, you also have a number. Your social security number is you. So there are many different ways to name something that is existing, okay, in the world. And we call that the communication type coding. So measurement, the same thing. We have many different kinds of coding. So we communicate the measurement by coding it, okay? And that's how we communicate the measurement, because you're coding with different kinds of units, and you're coding with different kinds of number system. So others working in metrology, okay, they can be able to understand what your measurement means. So you can say like, oh, from here to here is like 5 miles. So if you say 5 miles, the other person understand what you're talking about. Oh, you have to, like either drive or walk from this point all the way to here, 5 miles. And that's the measurement of length or distance, okay? And your instrument, okay? Your instrument is going to be your odometer, yeah, audio if you drive. So your odometer is going to be telling you, I'm going to drive from this point all the way to here. And your audio in your car got to show 5 miles, right? So your car is not a measurement device or instrument. You are the operator of that instrument. And what are you measuring? You're measuring from your home all the way to probably your school or something, okay? And this is the part that you're measuring, okay? And the quantity is length. The symbol is L, and the unit is 5 miles. Okay, a mile. So anyway, so what are we doing? We're coding this thing, the distance, with this. Okay, what do we use? We use a number and we use a unit. And that unit is a code. Okay, so I think you got it. So anyway, let's go back here. Okay. Alright, so this table, you have to know this. You can read it from here all the way to here. So this is your basic metrology principles. The discipline of measurement, what do we have to do? So the accuracy of a measurement can never be as great as that of the standard. Okay, again, accuracy. Every measurement that you're measuring, you're comparing that to a standard, accepted standard. So you got to compare your measurement to the standard. Therefore, your measurement can never go beyond that standard. Okay, if you go beyond that, can I say, like beyond that, it would be it'd be a mistake. You might have a little bit of tolerance zone above it, but no more than that. Okay, and again, standard is that we're taking it as the ideal thing. So therefore, any measurement that is done against that standard cannot go over that. And if you go over that, probably you can replace your measurement to that, but then it doesn't happen in the real life often. Okay. Another one is accuracy is diminished by errors. So if you make an error and you're careless about what you're doing, then you might not be getting a measurement that is comparable to your standard because you have lots of errors and you might be stressed. Or you might be using the wrong instrument, okay? You might be measuring the wrong part. A lot of things can happen from the environment. And we call it that accuracy is diminished because you're making errors. So therefore your accuracy is low. Okay. Calibration comparison to a higher standard. Calibration is nothing but you're comparing to a higher standard, meaning like a standard which is better than the accepted standard. Is a test for the accuracy. Calibration is nothing but checking accuracy, how accurate your instrument or your part is by comparing it to a higher standard. Repeatability is a usual test for the precision. And precision again is repeating. You're measuring 1 time, 2 times, 3 times, 4 times. All your measurement, you look at it. Oh, are they close together? Are they not close together? Okay, and that's called repeatability. And that is the usual test for the precision. So anyway, you can read all the way to 7. Okay, and you definitely need to know this rule because these are the principles of measurement, fundamental ones. All right, next thing. So here, this is just symbols, and these symbols are from a standard, and we call them ASMEY 14.5M, and this is for your ISO. Okay, this is just a symbol drawing for these quantities. So for straightness, if you go by ASME, you're gonna draw like this. If you go by ISO, you're gonna draw like that. Flatness, circularity, cylindricity, profile of a line like this, profile of a surface. This is all around. This is an angularity, your angles. Perpendicularity, your 90 degrees. Parallelism, okay. Position, like a GPS, yeah. This is concentricity. And then here is your symmetry. Continue. Circular run out, total run out, maximum material condition. So here you don't have to go into details. We're gonna encounter the same thing in a later chapter. Here all we have to know is the symbols and the quantities. We use the symbols to represent the quantities. That's what you have to know, okay? All right, that's it for chapter 1.